Hi, hello. So welcome to the session today. So today our topic is trigonometry. So trigonometry, in that we will cover the topic trigonometric ratios. Okay. So all right. So before we get into the trigonometric concepts, first we need to have some background on the right angle triangle and also Pythagoras theorem, right? So in your earlier classes, you would have already studied about different types of triangles and also what is Pythagoras theorem. So I'll quickly give a summary or a quick overview of what is Pythagoras theorem. So Pythagoras theorem is applicable for right angle triangles. Okay, let's say this is a right angle triangle. So I'm drawing with freehand, so it's supposed to be all straight lines, right? So this is a right angle triangle with this as a right angle, right? So let's name this triangle what it says are A, B, and C, right? So Pythagoras theorem, right? Mhm. Pythagoras theorem. So what Pythagoras theorem states is in a right angle triangle, let's understand what is this side hypotenuse. Yeah, I just wrote as a hype, right? This is hypotenuse, hypotenuse. And what is this side? This side is a side adjacent, adjacent side, we will call it as adjacent side to the A. And then this is opposite side to A. For the vertex A, this side is opposite, which is BC, that's an opposite side, and AB, that is adjacent, so this is a adjacent side. And the side which is opposite to the right angle, that means vertex B, that is your hypotenuse. So what Pythagoras theorem states is the sum of squares the sum of squares of the other two sides in a right angle triangle is equal to the square of the hypotenuse. Or in the other words, the square of hypotenuse is equal to the sum of the squares of the other two sides. Okay, so in the short form, I can write the hypotenuse square equal to opposite side square plus adjacent side square. Okay, so hypotenuse square is opposite side square plus adjacent side square. So what is hypotenuse here? If I substitute in the form of the sides, then this is AC square equal to what is opposite side? BC square plus what is the adjacent side? AB square. Or in other terms, I can write this as AB square equal to, I can just write in the order. AC square equal to AB square plus BC square. So this is Pythagoras theorem, right? So in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, right? So what are those other two sides? Opposite side and adjacent side. So in terms of the sides, if I can write, this is AC square equal to AB square plus BC square. Okay, now let's look at some examples, like how this Pythagoras theorem is useful. For example, I have a right angle triangle and I know one side. Let's say ABC is the right angled triangle with right angle at B, and I know two sides. For example, the hypotenuse is 5 and this side is 3, for example, 3 centimeters and 5 centimeters. So if I know two sides, I can find the third side, right? So just use this. So what is the Pythagoras theorem? If I apply the Pythagoras theorem in the adjacent triangle, that is AC square equal to the hypotenuse square equal to the sum of the squares of the other two sides, that is AB square plus BC square. So what is AC? AC value I know. So that is 5 square equal to AB. AB value I know, that is 3 square plus BC value I don't know. So let's keep as is. So BC square. So this is 25, and this is 9, and this is BC square. So what is BC square? 25 minus 9, that is 16. Then what is BC? BC is square root of 16, which is 4. So this is 4 centimeters if you want to write the units. So in a triangle, in a right angle triangle, if we know two sides, any two sides, it can be opposite side, adjacent side, or it can be opposite and hypotenuse. We can find the third side, whichever the side we don't know. In this case, we know hypotenuse and we know the adjacent side. We found what? We found the opposite side. So like that, Pythagoras theorem is useful or helpful in finding the third side if we know two sides in a right angle triangle. Now I will tell you why we are talking about Pythagoras theorem in trigonometry. Okay, so trigonometry is basically deals with right angle triangles and the ratios. So why those ratios are useful, I'll tell you. So where trigonometry is useful, for example, you want to measure the height of a certain pole, right? So if you have a meter, you can measure it, right? If you have, let's say, the pole is 5 meters length, and if you have a meter which can accommodate that 5 meters, you can just stand here and somebody at the top, and you can measure the length of the pole. Now, what what happens if you want to measure the length of a bigger object? For example, Everest, right? If you want to measure the height of the Everest, can we do that using a meter or a scale? No, right? So trigonometry is useful in measuring the heights of all bigger objects which we cannot measure using our normal scales or meters. So Everest is somewhere, right? Somewhere it's very tall, the tallest mountain in the world. Now, if I stand at one point away from the Everest, and if I look at the top of the mountain, so I can see the Everest. For example, let's say this is our Everest, right? This is our Everest, and I am somewhere here. It can be some hundreds of kilometers, or some 2 kilometers or 5 kilometers, some distance, right? If I join to the foot of the Everest, an imaginary line to where I am standing, if I draw a line to the top, then if I know this angle, 30 degrees or 40 degrees or 60 degrees, and I know how far I have been from the foot of the Everest. So if I know this distance, right, and if I know this angle, I can find this height. So I don't need to measure as long as I know one side and one angle. So that angle we will learn in the trigonometric ratios, how to find that angle and what is the value of that angle, right? So trigonometry is useful in finding the heights of larger objects, right? Using trigonometric ratios. So what are those trigonometric ratios and why we first talk about Pythagoras theorem? So Pythagoras theorem is helpful if you know two sides, you can find the third side. But here, if we know only one side, if we know one angle, right, we still can find the third side. So that is trigonometry. So let's look at what are those trigonometric ratios. So let me take one right angle triangle and explain you what these trigonometric ratios are. Let's say a this is a right angle triangle. Okay, and this is angle at A, and this is B, and this is C, right? Where is right angle? Right angle is at B. Now we know this is hypotenuse, and for the angle for the vertex A, this is opposite side, and for vertex A, this is adjacent side. Now there are 6 trigonometric ratios. Okay, so we can say this is angle A, right? The angle at A is angle A, and angle at C is angle C. So when we are talking about trigonometric ratios, it is respect to the angle from where you are looking at. So if I want trigonometric ratio at A, then this is opposite side and this is adjacent side. If I'm talking about vertex C, for C, this is opposite side, right? From which vertex you are, the opposite side is from that. So if you are looking at C, for angle C, the opposite side is AB and the adjacent side is BC. So it completely gets opposite when you look from different vertices. So you just make a note of that. So I'll explain you. So now I told about the trigonometric ratios, right? So there are 6 trigonometric ratios. We'll go one by one. So we have sine of A, sine angle of A, or sine A, we will write it as. What is the sine A? The sine A we can find using the formula. The formula is opposite side by hypotenuse. So opposite side by hypotenuse. So in this diagram, what is the opposite side for A? It is BC. By hypotenuse is AC. What if I want to find the same angle sine of the angle of C? So for sine C, which is the opposite side? The formula is same, opposite by hypotenuse. What is the opposite side for sine C? This is AB. So it changes based on which angle that we are trying to find the sine ratio, right? So AB by hypotenuse is same in a triangle AC. So if it is the sine A, this is the opposite side, that is BC by AC. If it is the sine C, then it is AB by AC. Hope you are getting it, right? Similarly, sine of A is one angle, which we call it as sine A. And similarly, cos A. What is cos A? This is a formula that is adjacent side by hypotenuse. So what is the adjacent side for cos A here? It is AB by AC. Similarly, we can write cos C. Cos C is also, the formula is adjacent by hypotenuse. What is the adjacent side here for C? That is BC. So BC by AC. Now, there is another trigonometric ratio, that is tan of the angle A or tan A. So sin A, cos A, tan A. So what is tan A? Tan A is basically the ratio of sin A and cos A. Or we can say opposite side by adjacent side. So what is opposite side here for A? That is BC. But what is adjacent side? AB. So tan A is BC by AB. Similarly, what is tan C? Tan C is, the formula is same, opposite by adjacent, but the opposite side changes here. For C, the opposite side is AB. So AB by BC. Okay, hope you got that. So these are the 3 trigonometric ratio. We have 3 more. I'll just explain. So sin A, cos A, and tan A. These are the 3 main trigonometric ratios. Okay, and the other 3 are reciprocals for this. Okay, so sin A is opposite by hypotenuse, and similarly cos A is adjacent by hypotenuse, and tan A is opposite by adjacent. Now we also have cosec A, cosecant A. Okay, cosecant A is 1 by sin A. Cosecant angle is the reciprocal of sine angle. So cosecant A is 1 by sin A. So what is 1 by sin A? The reciprocal of sin A. Sin A is opposite by hypotenuse. So this is hypotenuse by opposite. So the value just becomes like AC by BC. Understood? So that is cosecant A. Let's look at the other 2 trigonometric ratios. So we have cos A, right? So for cos A, the reciprocal is, secant A. Okay? For cos A, the reciprocal is secant A. And similarly for tan A, the reciprocal is cot A. Okay. So secant A, what is secant A? So secant A is 1 by cos A. What is cos A? Adjacent by hypotenuse. So this becomes hypotenuse by adjacent. So what is hypotenuse here? AC by adjacent is the AB. You can similarly write for cosecant C and secant C. You just need to reverse that. Then cot A. Cot A is 1 by tan A. Cot A is 1 by tan A. What is tan A? Opposite by adjacent. But cot A is reciprocal to that. So adjacent by opposite. So what is adjacent? AB by opposite is BC. If it is cot C, you just do 1 by tan C, opposite and adjacent. So that's how you need to do. So basically, these are 6 trigonometric ratios: sin A, cos A, tan A. Those are the primary trigonometric ratios. And then we also have reciprocals for these. That is cosecant A, secant A, and cot A. Cosecant A is the reciprocal of sin, and secant is the reciprocal of cos, and cot is the reciprocal of tan. So cot A is 1 by tan A, secant is 1 by cos A, cosecant is 1 by sin A. Okay. Now, how these trigonometric ratios are helpful in solving the problems. That's what our main objective is, right? So for this, okay, and also one important thing I need to tell you. Sometimes if they just specify the angle, they can uh, they can just call it as, let me just draw this, right? Sometimes they just call this as theta, right? A, B, and C. So this is the right angle. Sometimes we just call this as theta instead of saying A. A is also an angle. Theta is a sign that we use for angle. So if theta is here, then the opposite side is this, and this is the adjacent side, and this is hypotenuse. Okay, so based on that, we can do that. So the angle can be A or theta. So you can get sin A or sin theta, cos A, cos theta, based on what the value that they have given. Okay, now what I have done is, for our reference, I have just taken a screenshot from our NCRT book, so that we will see like a couple of problems we will solve from that. So that way it will be easy for you to see like which problem that I am targeting, right? Okay, so this is exercise 8.1. So far we learned what is a Pythagoras theorem, how to find a third side. If we know two sides using Pythagoras, we know. Now I just talked about the trigonometric ratios. In a right angled triangle, what is sine, cos, tan, cosecant, secant, and cot. Now, there, how those trigonometric ratios will be helpful, we will see here. For example, let's take the third problem here, right? Third and fourth, for example. So let's look at the third problem. If sin A equal to 3 by 4, calculate cos A and tan A. Okay, good. So let's do that, right? Sin A is given. So the third problem, right? Sin A is given. So it is 3 by 4. Okay. Now, what I will do is I'll draw a triangle, right? So that's the thumb rule. First draw the triangle. That way it will be easy for you to understand. When we have a triangle, it is easy for you to understand which is the uh, opposite side and which is the hypotenuse, that stuff. Okay, so this is our right angle triangle, and they're saying the angle is at A. So I'll take this as A, and this as B, and this as C. Now, sin A is given as 3 by 4. So can I say with some constant, right? 3k by 4k, I can do that, right? Because when I have a ratio 3 by 4, it can be 6 by 8, any multiples of 3 and any multiples of 4, right? If I multiply 3 by 4 with 2, then it is 6 by 8. So I cannot quantify the length. So what I am saying is 3 into the same factor, k. 3k, 4k is my length of each side. So what is sin A? In our principle, the formula that we learned, sin A is opposite by hypotenuse. So what is opposite side in this triangle? This is opposite side, and this is adjacent side, and this is hypotenuse. So what is opposite side for A? That is BC. So BC by AC, that value is what? 3K by 4K. Can I say that? So that means my BC is 3K, right? And hypotenuse is 4K. Now I know two sides. Can I find the third side? Yes, I can using the Pythagoras, right? So using Pythagoras, using Pythagoras theorem, what is our formula? The hypotenuse square equal to sum of the squares of the other two sides. So AB square plus BC square. So what is AC? AC we know, that is 4K whole square equal to what is AB? Is I don't know. So let's leave as AB. That's what we need to find, right? So that equal to AB square plus what is BC? 3K. 3K whole square. So this is 16K square equal to AB square plus 9K square. Then what is AB square? So I'll send that value to the other side. That is 16K square minus 9K square. So what is that value? 16 minus 9 is 7, right? Yeah, 7K square. One minute. Right. So AB is, then AB becomes square root of 7K square. That means square root of 7 and K. For K square, we can take out K. So AB is root 7K. Root 7 into K. So now I know the other side, the adjacent side I know. So I know all the three sides now. So the adjacent side is root 7K. This is what I found. Now, what was asked in the problem? So sin A is given. You need to find cos A and tan A. Now I know all the three sides, so I can easily find it, right? So cos A, what is cos A formula? Cos A is adjacent by hypotenuse, right? So what is the adjacent side here? AB, right? In this triangle, AB is the adjacent side, which is root 7K, right? AB by AC. AC, anyways, we know it is 4K, right? So cos A is AB by AC, where AB is root 7K by AC is 4K. So KK is a constant, the same factor, so we can cut it. So the answer for cos A is root 7 by 4. Okay, hope you understood this. So cos A is what? Root 7 by 4. And similarly, we need to find tan A. So what is tan A? Tan A is opposite by adjacent. So what is the opposite side here in this triangle? Yeah, we need to refer back to the triangle always, because the opposite side in this triangle is BC by AB. BC is the opposite side and AB is the adjacent side. What is BC? BC we know that is 3K, I guess. Yeah, 3K, and AB is root 7K. So 3K by root 7K. So KK gets cut. So 3 by root 7. So these are the values. So when you know one trigonometric ratio, we just draw the right angle triangle, and we found the third side using Pythagoras, and then whichever the trigonometric ratio that you want to find, you can just find it. Okay. Now we will take some other problem, and then we will see how to find that. Yeah, let's take maybe 8, right? 3 cot A equal to 4. Then we need to check whether 1 minus tan square A by 1 plus tan square A equal to cos square A minus sin square A. Okay, so they are asking us to prove 1 minus tan square A by 1 plus tan square A equal to cos square A minus sin square A. So basically what I need, I know cot A, I need to find sin, cos and tan, and then I need to equate left hand side and right hand side. Okay, first from the cot A, first let's find what is the other required trigonometric ratios. Okay. Oh, all right. So if 3 cot A equal to 4, okay, let's do the eighth problem then. This is how you will get in the board exams. 3 cot A equal to 4. They don't directly just ask you giving a triangle, giving two sides and ask you to find the third side. It won't be that simple, right? So you need to learn the concepts and you need to apply those concepts, right? So 3 cot A is 4. Then you need to prove that. So first I will find what is sine, cos and tan. Okay, that's simple. So cot A, then what I will do is these 3 I'll send to the other side. Then what cot A becomes? Cot A becomes 4 by 3. Okay. Then what is tan A? I need to find tan A as well, right? So tan A becomes 3 by 4. The reciprocal of cot, right? So it is 1 by cot. So tan is 1 by. So the denominator becomes numerator and numerator becomes denominator. So tan A is 3 by 4. Yeah. So I always suggest to draw the triangle, right? So yeah, let's draw the triangle first. Let's draw the right angle triangle. Okay, so the angle is A here. So A, B, and C. The right angle is here. All right. So what is the opposite side for A? This is opposite. This is adjacent. This is hypotenuse. Every time I suggest you to write the opposite, adjacent, and hypotenuse so that you don't get confused when here tan A is there. In the problem, if they ask tan C, then you need to take the angle at C, and then your opposite and adjacent sides differ completely, right? So always indicate from that vortex what is the opposite and adjacent sides. Okay, now I know tan A, so I will just use this. So what is tan A formula? So tan A is opposite by adjacent. So what is opposite side here? BC by AB. So what is the value of that? 3 by 4. I just introduced that K as a common factor for both so that I can assume the length, right? So 3 by 4. So what is opposite side here? BC. BC, I can say this is 3K, and the adjacent side I can say 4K, right? So I know this, I know this. I need to find hypotenuse now. So using which theorem? Pythagoras. So using Pythagoras theorem, we can find the third side. That's what we need. So what is the Pythagoras formula? AC square equal to AB square plus BC square. What is AC square? We don't know. We need to find. So keep AC square as is. And what is AB? 4K. So substitute that value. AB is 4K. So 4K whole square. Plus what is BC? BC is 3K. So 3K whole square. Now, AC square is what? 16K square plus 9K square, right? So that is 25K square, which is AC square. Now what is AC? Square root of 25K square. So now AC is square root of 25K square. So I can write 25 square root is 5. For K square it is K. So it is 5K, right? Now I know all the 3 sides. So using the Pythagoras, I found the hypotenuse. Now I can find any trigonometric ratio, right? So here in the problem, I wanted to show 1 minus tan square A by 1 plus tan square A equal to cos square minus sin square. So I need cos and sin also. So let's find what is sin and cos from this. So now sin A. So what is sin A? Opposite by hypotenuse. So what is opposite side here? BC by AC in our triangle, right? This is This is opposite, that is BC by AC. So 3K by 5K. So that's BC by AC, which is 3K by 5K. KK gets cut, so 3 by 5. That is my sin A. Now let's find what is cos A. Cos A is adjacent by hypotenuse. So what is adjacent? AB by AC. So what is AB? Go back to the triangle. AB is 4K, hypotenuse is 5K. So 4K by 5K. KK gets cut, so it is 4 by 5. So now I know sin A and cos A. Just get what is that equation, and I'll take the left hand side and right hand side, and I'll prove whether that's equal or not. So 1 minus tan square A by 1 plus tan square A. Okay. So what I need to prove? 1 minus tan square A by 1 plus tan square A is equal to, so what was that? Cos square A minus sin square A. Okay. That is cos square A minus sin square A. So these are two different values. So what I prefer is, I'll first take the left hand side and find the value, and then I'll take right hand side, find the value, and see if these are equal. Then I'll say yes, both are equal. If not, say no, they are not equal. Okay, now 1 minus tan square A by 1 plus tan square A. This is the left hand side. Right. 1 minus, what is tan theta? Tan theta we found, right? So from cot A was given, but tan A was reciprocal of that. That is 3 by 4. Okay. So 1 minus 3 by 4 whole square by 1 plus 3 by 4 whole square. This is plus. Now, if I take the LCM, right, this becomes 16 and 16 minus 9. I'm directly writing it, okay? So hope you know 3 by 4 square is 9 by 16. And if I take the LCM on the numerator side, it is 16. So here 1 is there. So 16 into 1 is 16 minus 9. Similarly, this becomes 16 plus 9 by 16, right? So 16, 16, I can cut it. So 16 minus 9 is what? 7 by 16 plus 9 is 25. So the left-hand side value I got as 7 by 25. Now take the right-hand side and find the value, RHS. So what was the RHS? Cos square A minus sin square A. Okay. So what is sin A, cos A values we know, right? So what is cos A? Cos A is 4 by 5. So 4 by 5 whole square minus sin A is what? 3 by 5 whole square. Okay. So this is also same. Like this is like 16 by 25 minus 9 by 25. So the LCM is 25 and 16 minus 9. 16 minus 9 is what? 7 by 25. So I got both same values, left hand side and right hand side. So therefore, I can say, therefore, left hand side equal to right hand side. That means whatever the expression they wanted me to prove, that is 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. That is proved. Okay. So these type of problems will be asked in the board exam. So here, what concepts that we have used? We have used a trigonometric ratios concepts. Cot A was given. First we found tan A. And then from tan A, we applied the formula that is opposite by adjacent. And I need to find the other side. So I used the Pythagoras theorem to find the third side. And then I also want sine and cos for that equation to be proved. So I found sin A and then I found cos A. And then I just substituted those values, tan, cos, sine values in the left-hand side and right-hand side. I got the values. I got it as both are equal. So that's how we need to solve. So basically what we need to remember here is we learn the concepts of Pythagoras theorem and trigonometric ratios in right angle triangle, and we just looked at the problem. Okay, cot is given. So what else we need? We need tan, we need sine, we need cos. So how to find those? So we learned the concepts. So using Pythagoras, I can find the third side. So that I did. And then we know the formula. If we know all the three sides, we can find sine, we can find cos, We got the values and then we just substituted. So always remember, be strong at your concepts, no matter what problem they give. Just think what is given and what is asked. How to get the values from, how to get the required values from what is given. So get those values and just substitute. Any problem, any complex problem you can solve. Just remember these thumb rules. Okay. All right. So that's about the trigonometric ratios. So thanks for watching. And if you guys have any doubts or queries or questions, you can reach me on my profile in Urban Pro. Okay. So reach out to me in my Urban Pro profile and I will be able to respond to you as soon as I can. Okay. Thank you.